Well, my name is Brian France. I have been asked by some friends to go over a little bit of the idea of uh, the theory on antennas. Um, I have a bachelor's in electronic engineering. That being said, that's a long time ago, and so I guess this would be named "What I Remember About Antenna Theory." Um, But what I wanted to do is start lower than a lot of things, because when you start, when you pick up the ham radio guide, uh, so the ham radio guide starts right about here. There's a certain amount of knowledge that they expect. So the ham radio guide will take you up to here, to where you can actually work with the ham radios, transmit, receive all over the world, that kind of thing. Okay, so the ham radio guide covers all this information. Okay, the problem is a lot of people are over here. Okay, so there's just a gap. So what I want to do is go through a series of things of what I remember about antenna theory, and even more, to get from here, which is 0, to 20%, because they expect 20% knowledge, and this would be 100%, or 99, 95, whatever. Nobody knows everything. So that being said, I'm gonna try to start it here, and so if this will be a series of short videos. If I'm starting too low for you and you understand that already, not trying to insult anybody, it's just that some people are starting here. So if you're like here, well, maybe jump ahead 1 or 2 sessions. So what I remember about antenna. So let's go ahead and start at ground zero. Where is 0? 0 is, what is electricity? I mean, a lot of people flip the switch on, come over here, you got this little switch, you go on, off, on, right? What happens? Why is that coming on? All right, it's electricity. Well, a lot of people, that's about as far as they know. So what electricity is the movement of electrons through um, a ferrous material. Now, some of these definitions are going to be a little simplistic, so don't get all hyper about it. I'm just trying to get you up to here. I'm not going to be exactly accurate on some things because it might take this much explaining when I can just explain it this much and it's a little off. So, besides memory from, I won't say how long ago, 20 years, 25 years, whatever. I've forgotten probably more about electronics than I remember, so let's just start where I was. So what's electricity is, here you have a wire. Let's call it a copper wire. All right, electricity is the flow of electrons. You have electrons, 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 electrons. They're all minus, 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 minus. Right? So electrons, if you remember from your particle physics, electrons are negatively charged. They sit there and you look down to the atom. Okay, here's your atom. Here you got electrons floating around your atom. Here and here you got protons and neutrons. So N and P's, right? Here's your E's, electrons. These are negative, protons are positive. Okay, so how does it keep electrons going around? If you have 3 protons and 3 electrons, you're pretty much balanced. If you have 4 electrons and 3 protons, you're unbalanced, and eventually it'll let go of that electron. And that's called radioactivity. Okay, radioactive. Okay, we won't get into that. That's too far. So basically, remember, you have a atom. You've got electrons floating around it. When you actually apply a voltage across it, a positive and negative voltage, it says, oh, these electrons go, hey, I now have a pull to go somewhere else. Okay, but they only work in a ferrous or metal. Okay. So what electricity is the flow of these electrons within the wire. I don't have to use. I think it's not working well. So you have electrons just sitting there waiting to go somewhere. I go over here and I apply a plus and a minus across that wire. The voltage. Okay. Voltage is a potential of energy. Okay. When I have a plus, well, guess what? These are minus charge. That's plus charge. all these guys start floating that way, right? So you have a current now, I, which is that, and then voltage is V. I'm not going to go too far into that, but you have a current because all of these negatively charged electrons go, oh, I'm being pulled towards the positive, okay? Now, it only works if you have something connected over here. It is a circle, okay? So you eventually have a loop, and how you get this voltage, the simplest way to get a voltage, actually, that shouldn't be dotted, right? It has to be a loop. Simplest way is to have a little battery, plus, minus. Boom, you now got a current. Okay? Now how much current does it have? Well, it depends on how much resistance is in here, okay? Because you have a current, if there was no resistance, which happens when they super cool this stuff, or super cool gold, I believe is what they do, for a superconductor. Brain's not working. So superconductor, they freeze it down to 000 Kelvin, which is like really freaking cold. And then there's no resistance, and then you get the ultimate current. Well, the battery's going to have its own resistance. Okay, so resistance is the resistance to the electrons moving. Okay, resistance is known as R. I won't go too far into it, but electrically, V times I, or current, equals R. And again, we won't go too far into it, but that's basically what it is. Okay. So right now we've got electricity going in this loop. But if you just hook up a battery to a wire, it's going to get hot. And because there's too much current, it can only carry so much current before it melts down. Okay. When it starts turning hot, it starts resisting the current. So actually, as it gets hot, it actually slows down the current. But what you want to do, so you're not burning up your wire, you want to put some kind of resistor in here. The resistor looks like this. That's a terrible resistor, isn't it? Okay. Battery actually looks like this. Alright, but okay. So that's your resistor. That's how electricity works. Okay. This is direct current, meaning you only have this plus and minus only, and that's what's charging that current. That's what's forcing that current to go somewhere. Okay, that's DC. So you have batteries or a DC power supply. You're only getting current one way, direct current. Okay. So the next thing to understand is AC. Well, what the heck is AC then? Well, I'm gonna leave this one up. I'll go over here. It might have been hard to see, so go over this real quick. Again, you got a wire. You've got a loop, because you have to get any kind of electricity, you have to have some return too, so you have to have a loop. Okay, and you have the electrons minus going towards the positive, and then of course they come around and it's just a big circle. Okay, so you have voltage, which is coming from the battery. By the way, a battery generically, now different alkali batteries are different than lead acid, but generically is 1.5 volts in a battery. That's terrible. Can't write. 1.5 volts in the battery. That's your voltage. That's your potential. How much current? Well, these little batteries, oh, maybe you could get about 10 amps through them the most, but they'd get real warm at that. So, again, and then the resistance to this current is R. That's done in ohms. Okay, ohms has to do with the resistance of the current. The current is I, and that's in amps. So voltage in volts, current in amps or microamps or whatever, and resistance in ohms. Okay, resistance in ohms. So remember, you got V times I equals R. So let's say we have 1.5 volts. We want to have 1 amp of current. How much resistance would that be? So voltage is 1 point. What that mean? Hold on. Helps if I wipe it off. So we've got voltage times current equals R. So 1.5, and we want how much? 1 amp times 1 equals 1.5 ohms. Right? VI. So that's how that works. Just real simply. There's a lot more to this, but this is just a real simple idea of what electricity is. Okay? So if that is DC, what is AC? Everybody over here is AC? These lights, your wall, all that works on AC. DC is like your car, 12 volts. You have a battery, it's 12 volts. You have an alternator, I'll go into it, it's basically a generator that goes in, that produces 12 volts. Okay? If you have a military vehicle, it's 24. So the voltage in the light switch is 110. Okay, I won't go into the fact that your dryer is at 220 and there's other stuff in your house. Your house is basically 110. Unless you happen to be in Europe, then it's 220. So, I'm not going to go into other countries. In America, it's 110. We'll just leave it, so we'll just leave it at that. So what if that's DC, what is AC? What is AC? AC. Alternating current. Well, it's the same basic thing, but you're going to have alternating current. And I won't go into too much why, but so AC, you're going to have the same loop. Alright? Okay, and here's your voltage supply. And I forgot about the resistance. And some kind of resistance. Okay? There's your wire. Now, what is AC? AC is where you get current going one way or another, real quick. Okay? So this plus and minus switch off. Alright? So what AC is, it's going to be a generator. They usually draw them like that, right? Generator, G-E-N. Generator, alternator, whatever you want to call it. It's really not a generator, is DC. Let's call it an alternator. A turbine in a, so in your, where this is coming from a lot of times, let's say it's a water turbine in a dam. Well, it spins a big turbine. The turbine creates AC, okay? Now what does that mean? It means it's not, there is no plus. There's a plus minus for a short time, and then there's a minus plus for a short time. How many times does that change a second? In the United States, it's 60 times a second. So it's plus minus, plus minus, plus minus, 60 times a second. In Europe, it's 50 times a second. So U.S. and EU. And a lot of the world is actually 50 times a second, not just Europe. Okay, so that is what it, times a second is hertz, H-Z. So hertz, H-Z times P-E-R per second. Alright, sec. So hertz is how many times per second your oscillation changes. Okay, plus, minus, minus, plus, plus, minus, minus, plus. Now why does it do that? Why isn't it just positive, negative, that's it, quit doing that, right? Well, you're going to find out that direct current actually uses up more energy because it creates more resistance in your wire. AC creates less resistance, so it turns out that AC travels long distance is better than DC. Just for the history of it, Emerson's original electric power to, I think it was, well, New York City was the first one to get power. Then it was actually Cripple Creek, Colorado. Then it was Paris, France. So it was in between those two, which is interesting. Anyway, so Emerson said DC's great. Well, he had a lot of loss across his wires because the resistance was high and it heated up. So you basically had a lot of resistance losing power. This is a waste of power. AC can travel a lot longer distances without losing as much power. Okay, that's what we use now. Now what creates that? We're going to have an alternator which actually creates alternating current. Okay, so this generator, it's not really a generator, I should really call it an alternator. What an alternator is, to explain what an alternator is, when you have a coil of wire and you have something going through it, a hard, a ferrous material, iron, something like that. You take a magnet, you got a magnet coming by here at speed. That magnet induces a current into that coil, and it goes out, and all of a sudden you get some kind of voltage. And I have a cat. Cat, I'm busy. So if it goes by there, if you're going this way, what it's going to do is all of a sudden you're going to have a plus and a minus. Hold on, clean it up. And a minus as that magnet goes by there. So it's going here, right, and then here as it goes away, right? So right here, the coil will have zero potential. As it's coming up, it'll be plus. As it's going away, it's minus. Okay, so it'll induce a voltage going up and then down as it goes back. So your voltage will look like zero. It'll go up and then down, and that's it. As that magnet goes by there. Well, guess what? You just created AC, plus minus, right? Well, how would you keep that going by? You can't just keep waving a magnet by a coil. What you're going to do, I should have put that somewhere else. So that one looks like this. You have something going like this, up and then down and flat. So you got flat, right? That's with just you waving a magnet against a coil. Well, what happens if there's a reason I drew that in a bit of an arc, without even meaning to. So let's say that you replace it with a wheel. We're going to have a wheel out here. You have a magnet, all in equal distances across around the wheel. Right? That's distance, it's equal. So now you're going to spin it. What's going to happen is this is going to go by, this is going to go by, and so it's going to right? You're going to keep sending magnets past that coil. What are you going to get instead of flat? What you're then going to get is like this. That's called sinusoidal wave, right? AC. So again, 0 plus minus. All right. In your house, this current comes down the line. I believe 20,000 volts. Then it gets broke down to, I don't remember. There's an intermediate one. I don't remember the voltage. But in the end, you're coming out of your plug in the wall. It's one. Hold on, can't do this right. 10. That's 110 plus, minus. That's from here to here, 110. Okay. So that's how you get 110 coming out of your socket in your wall. Now that's a big deal because you're gonna well, we'll talk about how this works later. This is probably enough for the first one. If you have any questions, put them in the comments and I'll try to answer them. So that's AC, okay, and that's DC. Easiest way to remember DC is basically batteries, although your charger for your phone is like 5 volts. Your charger for a lot of drills is 12 volts. Your car's 12 volts. That's all DC. Your regular light bulbs are AC. Those are 110, okay. Your motors, all that kind of stuff. Your furnace usually is 110. Your dryer is 220. All it means is it's a bigger sinusoidal wave. Okay. So that's it for this video. I will continue on these videos. Let me know how you like them and how you want me to change them. If you have any questions, just put them in the comments and I'll try to get back to it. Thanks for watching.